Now that we know how to write a chemical reaction and balance it, we are going to look at different types of chemical reactions. Chemical reactions can be categorized in a few ways. One way is by looking at how the reactants interact with each other, or you can look at the types of reactants and products involved, or you could look at patterns between common observations that are made during the reactions. We're going to be going over 5 different types of chemical reactions in this video. Our first type of chemical reaction is called a combination reaction. A combination reaction has 2 or more reactants that combine together to form a single product. A general equation that we could write to show what's happening in these reactions are that A and B, 2 fictional generic reactants, form AB, a single product. One common example of a combination reaction is the reaction between charcoal, which is solid pure carbon, and oxygen gas. They combine to form carbon dioxide, and if you've ever used a charcoal grill, you are familiar with this reaction. When you light the charcoal, it begins to react with the oxygen gas in the air, and it forms carbon dioxide. You're left with a pile of ashes because much of the carbon from the charcoal has reacted with the oxygen and left in the form of a gas. So you have less, it looks like you have less at the end than you do at the beginning, but that's because you have gas, carbon dioxide, that is leaving the area. Another type of reaction is the opposite of a combination reaction, and this is called a decomposition reaction. A decomposition reaction has a single reactant that then breaks down to form 2 or more products. So the general equation for a decomposition reaction is the opposite of the general equation for the combination reaction. We see a single reactant AB producing multiple products A and B. A common example of a decomposition reaction is the reaction that we see when we have H2O2, commonly known as hydrogen peroxide, when it breaks down. You'll notice that whenever you buy hydrogen peroxide at the store, it's always in a dark brown container. That's because it is very susceptible to breaking down as a result of light rays. And so it needs to be in a very dark container. It breaks down into water and oxygen gas, which is seen at an accelerated rate when we put it on a wound. That wound accelerates the reaction of the hydrogen peroxide breaking down, and the bubbles that we see are pure oxygen, and it's cleaning out the wound with the pure water that's left behind. A single replacement reaction is one in which we have a lone metal that switches places with a metal that's in an ionic compound. In these reactions, we see that the reactants are a single element and an ionic compound. And then the single element switches places with the metal in the ionic compound, leaving a different single element in a different ionic product. One neat example of a single replacement reaction is when we put pure copper in a solution of silver nitrate. When that happens, the silver replaces the copper, or rather, the copper replaces the silver. So I'm going to cross that out. It's the copper that replaces the silver in the compound. The copper and the silver, they trade places with who is bonded to the nitrate. We leave behind, the copper now becomes part of copper nitrate, and silver, pure silver, is left behind. Here's what this reaction looks like. So when we have pure copper in a solution of silver nitrate, over time, those copper ions are then released in solution, which gives the solution a bluish color from the copper. And the silver starts to form silver crystals on the copper, which are fairly delicate crystals that are very silvery looking. They get shiny, just like you would expect silver to look like. Another type of reaction is a double replacement reaction. So instead of two ions switching places, we actually have two pairs of ions switching places. In a double replacement reaction, the ions in two ionic compounds switch partners. So if we have a general equation, we see that we have two ionic compounds, and the metals A and C, because the metal always comes first in an ionic compound, they're going to switch places. So now A is bonded to D and B is bonded to C. And actually, a better way of writing that would be CB. Since C is the metal, it should go first in that compound. An example of this reaction is when potassium iodide and lead nitrate, both which are clear liquids, when they're mixed together, the lead and the potassium switch partners so that we are left with potassium nitrate and lead iodide. When they switch partners, the lead iodide is an insoluble compound, which means it's going to come out of solution as a solid. It also has a very distinctive color, so it's very easy to see when it is produced. I have a GIF of this. Let's take a look. We have two clear liquids. When they are added together, we see that precipitate formed. This precipitate is very brightly colored, and if we were to watch this video for a while longer, we would see that it's actually forming a very fine powder that will settle out of solution eventually. Our last type of reaction is called a combustion reaction, and you may be the most familiar with this type of reaction. We think of combustion as burning, and oftentimes if you see burning, that is an example of a combustion reaction. A combustion reaction is a reaction between a compound and oxygen, and these reactions produce a lot of heat. A reaction that produces heat is known as an exothermic reaction, as we will be learning about later in the semester. The combustion of something called a hydrocarbon, and that is a compound that contains hydrogen, carbon, and sometimes oxygen. They always produce water and carbon dioxide. So an example of a combustion reaction that you may be familiar with is the combustion of butane, C4H10. When butane burns in a butane lighter, or in this case, a butane blowtorch used to caramelize the top of a creme brulee, it reacts with the oxygen in the air to form carbon dioxide and water. Now, just because you add two things together, it doesn't mean that a reaction is always going to occur. When a reaction occurs, there's a lot of factors that come into play: solubility of products, reactivity of reactants. Several different things will affect whether a reaction occurs. So when you are combining substances in our lab in the next folder, you're going to be looking for signs of chemical reactions, which we talked about in our last lesson. Now, if you don't see any signs of a chemical reaction occurring, that means no reaction has occurred, which we will see at least one example of in our lab for this week.